Yeah, very good morning to one and all. Today, I'm going to just revise and we are going to solve the problems what we have seen in the last class. That is load curve and load duration curve. Then the connected load, maximum demand, load factor, diversity factor. Like that, everything we are going to calculate today. The today's class. So first, just revising. So what is meant by the connected load? Connected load is nothing but sum of the total loads connected to that particular power system. That is called the connected load. That is nothing but sum of the total loads connected to the power system. What is the maximum demand? Maximum demand is nothing but it is the greatest demand on the load, it is the greatest demand of the load on the power station during a given period of time. That is, for example, if we have taken 24 hours of a time, in that 24 hours, what is the greatest demand of the load on the particular power station? That we have to note down. So next is demand factor. Demand factor is nothing but maximum demand divided by the connected load. So demand factor is always less than 1. Next, coming to the, like if you see this picture over here, this is the load axis in kilowatt or megawatt. This is the time axis in hours. So from this day, this is a load curve, daily load curve. So from this, what is the maximum demand? So that maximum demand we have to find out either from the data or otherwise after drawing the load curve or load duration curve, we can easily find out this maximum demand. So next is load fact. Next is average load. So what is the average load? Average load is nothing but average of loads occurring on the power station in a given period of time. That is in a day or in a month or year. That is average of load occurring on the power station in a given period of period of time. So that is known as average load or average demand. So as I said, load is nothing but a demand. Okay, so whatever the load we are expecting, that is the demand of that particular system. So load is nothing, load or demand is same. So next is what is the formula for load factor? Load factor is nothing but average demand divided by the maximum demand. So how to calculate this average demand? Average demand is nothing but unit generated divided by time in hours. Unit generated divided by time in hours. Unit generated, say for example, if we have taken 24 hours of time, so unit generated in 24 hours of time divided by time in hours. So next is reserve capacity. Reserve capacity, I think plant capacity minus the maximum demand is nothing but the reserve capacity. This is the reserve capacity. So next, coming to the diversity factor. So what is meant by diversity factor? So diversity factor is defined as ratio of sum of individual maximum demand to the maximum demand of the power station. So sum of individual maximum demand to the maximum demand of the power station. So that is meant by diversity factor. That is sum of individual maximum demand to the maximum demand of the power station. So this diversity factor, if you see, it is always greater than unity. Diversity factor is always greater than unity. So that is nothing but maximum demand is less than sum of individual maximum demand. So it will be less than unity. So if the diversity factor increases, automatically the cost of the generation of power is less. So we want this only. Cost of the generation should be less so that we can enjoy with the least tariff, tariff. So next, coming to the problem. Yeah. So a generating station has a following load. A generating station has a following load from 12 p.m. to 5 a.m. From 12 p.m. to 5 a.m. That is 500 kilowatt. Next 5 a.m. that is 12 midnight to 5 a.m. 12 midnight to 5 a.m. is 500 kilowatt. Next 5 a.m. to 10 a.m. 5 a.m. to 10 a.m. is 800 kilowatt. 10 a.m. to 12 noon. 10 a.m. to 12 noon, 2000 kilowatt. From 12 noon to like that that is after 12 noon. That is 12 1 p.m. 1 p.m. to 2 p.m. is 1000 kilowatts. Okay, 1000 kilowatt. Next 2 p.m. to 5 p.m. is 2500 kilowatt. Next 5 p.m. to 8 p.m. is 2000 kilowatt. So next 8 p.m. to 10 p.m. is 1500 kilowatt. Next 10 p.m. to 12 midnight is again 12 midnight is 1000 kilowatt. So first what we have to calculate is draw the load curve and load duration curve. Next to determine the number and size of generating units and also the plant load factor. So these three factors we need to find out. So we have to draw the load curve and load duration curve, and we have to determine number and size of generating units. Next is we have to find out the plant load factor. Plant load factor and load factor is same. So coming to the uh, load curve. So load curve. So always this axis in time in hours. So you can take like 12 midnight to 12 midnight. I am taking 12 midnight to 12 midnight. So 2 2 hours scales I am taking. So you can also take 1 hour scale also. Nothing wrong in that. Okay. So 2 2 hours scale I am taking. So I'm taking this as 2 centimeters like that, or 1.5 centimeters like that. So like 1.5 centimeter as 2 hours, 2 hours I'm taking from 12 midnight to again this 12 midnight. So here I'm taking load in kilowatt. So I'm taking the scale as 500, 1000, 1500, 2000, 2500. If you simply like only if you simply write like only load without units, the whole load curve is wrong. So even though everything is correct, so units are very very important. This is in load in kilowatt or whatever they mentioned. If load in megawatt means you have to draw, you can also take load in megawatt. And here time in hours. Okay, time in hours. So hours also you have to write simply like the time or period if you like. So that will be of different meaning. So hours unit is very very important here. So now what we are doing is we are based on the problem we are plotting this curve, that is load curve. So like based on the data, based on the problem data, that is 12 midnight to 5 a.m. 500 kilowatt, 5 a.m. to 10 a.m. 800, 10 a.m. to 12 noon 2000 kilowatt. Like that, what we are doing is we are plotting. So 12 a.m. to 5 a.m. 12 a.m. to 5 a.m. that is 500 kilowatt. So next is 5 a.m. to up to 10 5 a.m. to 10 a.m. So 800 kilowatt. So 800 kilowatt. It is up to 800 kilowatt. Approximately it is coming over here 800 kilowatt. So again 10 to again 12. 10 to 12 is 2000. Next 12 to 2 is 1000. So 10 to 12. So 10 to 12 is 2000 kilowatt. So next 12 to 2 is again I think 1000 kilowatt. Okay, so next 2 to 5, 2500, 5 to 8 is 2000. So 2 to 5 is 2 to 5 p.m. is 2500. Next 5 to 5 to again 8 is 2000. Next again 8 to 10 is again 1500 kilowatt. Next 10 to 12 is 10,000 kilowatt. So this scale, I'm taking 500 500 kilowatt like that. So you can also choose 1000. So the graph will be the units. Also, the scale will be very very less. It will come very for the better understanding. So all units are in so, like multiples of 500. So 500, 2000 like that. So I have taken like 500. So based on the this data that is load, you have to choose the scale, correct exact scale, so that you can get the exact. So this is of your load curve. Next, coming to the load duration curve. Load duration curve. So what we have to do is we have to form a small table like that for easy doing. Okay, so without any confusions, you can easily do. This table will not take more than 1 minute also. So, so in this thing, I have taken like load in kilowatt. So here duration in hours. So this is duration in hours. So very important here, duration. This is not time in hours. This is duration in hours. Okay, duration in hours. This is in load in kilowatt or megawatt. So load in kilowatt. So what I am doing is I am sorting this load in descending order. I am sorting all this load in descending order. That is, so here if you see the load, so 2500, 2000. So whichever is greater, I am sorting. That is in descending order. So first is 2500, next to 2000, two 2000s are there. Next 1500, next thousands, then 800, 500 like that. I am sorting in descending order. First you sort in descending order and write like this. That is 2500, 2000, 2000, 1500, 1000, 1800, 500. Next, you have to write like duration in hours. So 2500 kilowatt remains for how many hours? 2500 here remains for how many hours? So from 2 p.m. to 5 p.m. So 2 p.m. to 5 p.m. to 3, 4, 5. So 3 hours is there. Okay. So I have to we have to write here 3. So next to 2000. 2000 remains for how many years? Sorry, how many hours? Like 10 to 12. That is 2 hours. 11 and 12. So 2 hours. Again, one more 2000 is there. 5 to 8. So 6, 7, 8. 3 hours. Okay. Like 2000 for first is for 2 hours. So 3 plus 2. So you can write here 2. So 3 plus 2 is 5. So you can write here as 5. Okay. So again 2000 remains for again 3 more hours. So 5 plus 3 is 8. Okay. So again coming to the 1500. 1500 you have to see. 1500 how much? Yeah, 1500 here. 8 to 10. So 9 and 10. 2 hours. So 1500 for 2 hours. Okay. So don't write like here 2. Okay. So here you can write here as 2. Okay. So 8 plus 2 is 10. 8 plus 2 is 10. So again 1000 remains for again another 2 hours it seems. Yeah, 1000 remains for 10 to 12, 11 and 12, 2 hours. So next 12 to 2, again 2 hours. So you can write there as 4 or 2, 2 like that also you can write. So I am writing here 1000. So here 2. So 10 plus 2 is 12. So again 1000 for 2 hours. So 12 plus 2 is 40. So again 800. 800 how much? How many hours? Yeah, 800 how many hours of duration? Yeah, 5 to 10. So 6, 7, 8, 9, 10. So 5 years. So 5 years you have to add. So 14 plus 5 is 19. So again 500 how much? Yeah. Again 500 how much? 12 to 5. 12 to 5 means again 1, 2, 3, 4, 5. So 5 years. So 5 years you have to add. So 19 plus 5 is 24. So 24 hours we are getting as a whole duration. So don't you can write like the duration, then other at last you can add, or otherwise meanwhile if you are writing here like 2 here and keep on adding, it is very easy. So duration in hours is 3, 5, 8, 10, 12, 14, 19 and 24. So here what you do is, so now the job is very simple. Okay, I think this table, I think hardly 1 minute it will take. If you write, if you just calculate and write, hardly 1 minute it will take. And while drawing this table, units is very wherever you write units is very important. Load in kilowatts like that you can write, or otherwise simply you have to keep on writing all like a 2500 kilowatt, 2000 kilowatt like that. So instead of writing more kilowatt, so here in as a whole I am writing load in kilowatts, duration in hours, like that I am simply writing. So here units is very, very important. So units carries 2 or 3 marks, even though 10 mark question if you are getting, like if you are not writing the units, so only half of the marks will be awarded. So units is very, so now the job is very, very simple over here. So just we have to plot here. So this axis I have taken as load in kilowatt, same scale I have taken. Okay, 500,000 like that, same scale. This duration in hours. Whereas previous load curve, if you see, this is time in hours, this is in duration in hours. So if you write time in hours, this is wrong. Okay, this is not time in hours, this is duration.
అంత
Duration of time in
continuously అంత
hours.
టైమింగ్
Like
చూపిస్తాను
that,
నాకు
you have to write.
ఏ వద్దు అమ్మో అడిగా
Duration of time in hours you have to write. Next, simply like that you have to plot. So 2500 remains for how much duration. So duration I have taken as 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 and 24. So 2 units I have taken. You can also take 0, 1, 2, 3 up to 24, depends on your thing. So for simplicity I have taken 2 units. So now we have to plot. So 2500 for 3 years. So 2500 kilowatt for 3 years. So up to 3 years you have to plot. 2500 for 3 years. Next, again 2000 for 5 years. So 2000 for, you just extend up to 5 years. Okay, so again 2000 for again 8 hours. So you can combine here. So 2000, 2000 kilowatts are there. So this will remains for 8 hours. So again this 2000 remains for 8 hours. So again 1500, 1500 sorry 1500 remains up to 9 hours of duration. Sorry, 10 hours of duration. So here up to 10, 1500 up to 10, up to 10. Next is 1000 I think 12, 14, so 14, so 10 to 14 directly, because two thousands are there, so directly 14, so up to 14 hours. So next, 800 up to 19 hours. So 800, so approximately here 800 hours. Okay, so next 500 up to 24 hours, 500 up to 24 hours. So easily you can draw this load duration curve. So if you not okay, draw this okay table, if you are not coming up with a table directly like that, if you are plotting also you can do, but little bit it will be confusing sometimes. You will wrongly plot 1 or 2 units, okay, so while calculating little bit it will become confusing. Again you have to rub this diagram, again you have to draw, like that many confusions will come. So simply if you draw this tabular column with 1 minute, easily you can draw. After this, very, very easy. I think hardly 5 minutes is more than enough for drawing this whole load curve and as well as load duration curve. So up to this 5 marks, 5 mark question. Okay, sometimes they will ask him 5 mark question to draw the load curve and load duration curve. Very, very simple. You have to draw this thing now, you can easily draw the load duration curve also. So next is number and size of generating units. So this is of 2500 megawatt, sometimes in the problem itself given. So now we have calculated, so directly problem itself will be given here, so you just no need to worry about that. So next is plant load factor. So what is the formula for plant load factor? So plant load factor is nothing but average load divided by maximum demand, or average demand divided by maximum demand. Okay, so now we have to calculate average demand. So what is average demand? Average demand is equal to unit generated, or okay, so energy generated divided by time in hours. So unit generated divided by time in hours. So here unit generated we have to calculate. So it is also very, very simple. So you have to go to the problem whatever given. Yeah, unit generated. So this is 5 hours duration. 12 to 5 years, 5 hours. 12 midnight to 5 a.m. is 5 hours. So 500 into 5, 500 into 5 plus, yeah, here 500 into 5 plus 500 into 800, sorry, 5 into 800. So again 800 remains for how many hours? So 800 remains for again 5 hours. So 5 into 800 plus, so here 10 to 12. So 2 hours plus 2 into 2000 plus again 2. 2 into 1000 plus 2 to 5 means 3. So 3 into 2500 plus 5 into 5 to 8 is 3. So plus 3 into 2000 plus 8 to 10 is 2. So plus 2 into 1500 plus 10 to 12. Again 2. So 2 into 1000. So like that, we have to add so that you can get the total energy generated in 24 hours. So total energy generated. So if you add all these things, 5 into 500 plus like that, all if you add, okay, 3 into 2000 plus 2 into 5500 plus 2 into 1000, that will gives the answer of 31,000 kilowatt hour. 31,000 kilowatt hour. So this is a energy generated because we are adding time also here now. So energy generated. So the unit is here is kilowatt hours. Kilowatt hours. You have to very careful while writing the units. If you simply like that write like kilowatt, this is wrong. This is kilowatt hours. Okay, so kilowatt hour. So next we have to calculate the average demand. So average demand is nothing but unit generated divided by time in hours. So unit generated, what is unit generated? 31,000. Okay, 31,000 divided by time in hours is 24 hours in a day. For a day we are taking, so 24 hours. So if you divide this, you can get 1291.67 kilowatt. So this is of your average demand. So you have to highlight like this so that easily we can know what is Samsung. So average demand is 1291.67 kilowatt. So what is plant load factor? What is plant load factor? The formula average demand divided by maximum demand. So average demand we have calculated. Average demand we have calculated like 1291.67 kilowatt divided by what is the maximum demand? What is the maximum demand? Like we can identify like this also from the problem direct away. If you see here, and which is the maximum, that is the maximum demand, maximum load, that is the maximum demand. Or otherwise you can come to load curve. So in this load curve, which is the peak, that you have to identify. So by seeing here clearly you can understand this 1200, sorry, 2500 kilowatt is the maximum demand. Like that also you can identify. Or otherwise load duration curve. Load duration curve, if you just see now, simply like that, by seeing here itself, by seeing the first unit is just topmost, how the that curve is starting, that will be the maximum demand. So by that also you can identify this load duration curve. So while drawing the load duration curve, one thing you have to keep it in the mind, always the load duration curve has to be in the decreasing order. Why? Because we have sorted all the units in descending order here. So always it should be moving in the descending order like this. Descending order. It should be decreasing. Okay, then your thing is correct. While sorting itself, you can easily understand. Again, while drawing also sometimes by mistake also don't do the mistake. Why? Because you have to always plot it like this curve always should be in the decreasing order. That you have to keep it in the mind for easy understand. Okay, because you have to get full marks in this particular like topic. Full marks in the particular topic. That's why I'm repeatedly telling you. Okay. So here if you see, so what is the maximum demand? That is 2500 kilowatt. 2500 kilowatt. So that is substituted over here. So what you have to write is you have to write the formula. Then after substituting, so when substituting, you will get the plant load factor as 51.67 percentage. Okay, into 100 you have to do because this is load factor. Simply like that 0 point is wrong. So plant load factor always should be in demand factor, and everything should be in percentage. Okay, demand factor, diversity factor. If the factor, the word is coming like factor, you have to multiply with 100. So but by 100 means multiply 100 means it is in percentage. So percentage you have to write. So 51.67 percentage. Okay. So plant load factor it should not be in the decimals. Okay, it should be in the percentage. So we are multiplying with the 100. So this is of the like plant for calculating the plant load factor. Next, so this problem is completed. Very very simple. Like hardly it will take 5 to 10 minutes. More than that, I think if you are taking more than that, you need some practice. Hardly 5 to 10 minutes like that easily you can complete. But the units are very very important. Here percentage, here average demand in kilowatt or megawatt, whatever it is given there in the problem. Here total energy generated in kilowatt hour. Next, here the load duration curve, the units, load in kilowatt. Next, duration in hours. Next, here also units is very very important. Next, load duration curve also unit is very very important. So coming to the next problem. Yeah. So in this problem, in this problem, so what is given here in the problem? The maximum demand on the power station is 100 megawatt. If the annual load factor is 40 percentage, calculate the total energy generated in the year. So what is given here? Maximum load demand. Maximum demand on the power station is given. Annual load factor. Annual load factor also given in percentage. So they are asking to calculate the total energy generated in a year. So total energy generated in a year, that is nothing but maximum demand into load factor into hours in a year. So if they are asking the total energy generated in a year, you have to take it as year or daily or monthly, like that also you can go do it. Okay, so here it is asked in year. So that is nothing but maximum demand into load factor into hours in a year. So what is maximum demand? So maximum demand already given. Okay, so always like energy should be in kilowatt hour. Even in our home also, I think you have already seen in your energy meters that is mentioned in kilowatt hour. Okay, always you're reading whatever the load you consume, that is displayed in kilowatt hour. So what we are doing is, instead in the problem it is given like a megawatt, so we are converting that megawatt into kilowatt. So all the units should be in kilowatt. So what we are doing is 100 into 10 to the power of 3 kilowatt, like that we are taking. So maximum demand 100 into 10 to the power of 3 kilowatt into load factor. So load factor is 40 percentage. So 40 percentage is nothing but 0.4. Okay, so 0.4 here. Next into hours in a year. Hours in a year easily you can take. That is 24 hours into 365 days, or otherwise 8760 directly. That is 24 into 365 is equal to 8760. Like that also directly you can take. So if you calculate like this, you can get 3504 into 10 to the power of 5 kilowatt hour. Okay, this is the energy generated per year. Next, problem is, a generating station has a connected load of 43 megawatt and the maximum demand of 20 megawatt. Okay, connected load is 43 and maximum demand is 20 megawatt. Unit generated is 61.5 into 10 to the power of 6 per annum. Okay, clearly it is given per annum here. calculate demand factor and as well as the load factor. Okay, so demand factor and as well as load factor we have to calculate. What is the formula for calculating the demand factor? So demand factor is nothing but maximum demand divided by the connected load. Okay, so maximum demand, what is maximum demand? So maximum demand is 20 megawatt. So 20 divided by connected load is 43 megawatt. So 43 directly like that we are taking. So both the units are in megawatt. So that directly we are taking. Or otherwise, if one unit is given in kilowatt, other unit is in megawatt. Either you have to take in kilowatt or in megawatt. Okay. So it is given in megawatt. So directly we have taken like megawatt. So demand factor is 0.465. Okay, so next is average demand. So average demand is nothing but unit generated per annum divided by hours in a year. So that is the formula for that is unit generated divided by hours in a year. So unit generated per annum, here per annum. So normally per day we have solved, no, in the previous problem per day we have solved. So unit generated per annum divided by hours in a year. So what is unit generated in a year? Sorry, here it is in the problem it is given 61.5 into 10 to the power of 6. Okay, divided by hours in a year. So 8760. Direct 4 into 365 also you can take. That is nothing but while calculating it will give the answer of 7020 kilowatt. Next is load factor. Load factor is nothing but average demand divided by maximum demand. So simply for finding out the load factor, we have to find out the average demand. So for average demand, first we are calculating, that is unit generated divided by, per annum divided by hours in a year. So average demand we have calculated divided by maximum demand we know. So this is in kilowatt. This is in kilowatt. So average demand divided by this maximum demand, that is 20 into 10 to the power of 3. So this is also in kilowatt, that is 20 megawatt. We are converting 20 megawatt to kilowatt. So 20 into 10 to the power of 3. So that is nothing but 0.351. That is nothing but 35.1 percentage into 100. So 35.1 percentage. Okay, so coming to the next problem. Yeah, next problem. A diesel station supplies the following loads for various consumers. A diesel station supplies the following loads to the various consumers. The first one is for industrial consumer, like 1500 kilowatt, commercial establishment 750 kilowatt, domestic power like 100 kilowatt, then again domestic light for 450 kilowatt. If the maximum demand on the station is 2500 kilowatt and the number of kilowatt hour generated per year is 45 into 10 to the power of 5, determine first a diversity factor and as well as annual load factor. Here annual load factor is asked. Okay, so first we have to calculate diversity factor and as well as annual load factor. So what is the formula for diversity factor? So diversity factor is nothing but sum of individual maximum demand divided by the maximum demand of the power station. Okay, that is the formula. You have to keep it in your mind. That is diversity factor is equal to sum of individual maximum demand divided by maximum demand on the power station. So sum of individual maximum demand. So individual demand is given, that is industrial, commercial, domestic power and domestic light. Individual maximum demand is given. So individual load is given. So what we have to do is we have to add all these things, 1500 plus 750 kilowatt plus 100 kilowatt plus 450 kilowatt divided by maximum demand. Maximum demand 2500 kilowatt. So that is nothing but if you calculate, if you take your scientific calculator and calculate 1.12, that is the diversity factor. So next is average demand. So what is the average demand? So average demand unit generated per annum divided by hours in a year. So unit generated already given unit generated per annum. That is 45 into 10 to the power of 5. So 45 into 10 to the power of 5 divided by hours in a year. 24 into 365. That is nothing but 8760. So if you calculate directly, you will be getting 51 513.7 kilowatt. Okay, that is the average demand. So next is load factor. Load factor, how to calculate load factor? Load factor is nothing but average load divided by maximum demand. So what is average load? That is 513.7 divided by maximum demand 2500 kilowatt. So that is nothing but 0.250. So that is load factor. So into 100. So 20.5 percentage. Okay, so understood, no? So diversity factor is nothing but sum of individual maximum demand divided by maximum demand of the power station, average demand divided by unit generated per annum. So whatever is given in the problem, per annum or per day or per month, whatever you can take, divided by hours in a year or hours in a month or hours in a day. So here it is year, so hours in a year. Like that you have to calculate. So very easy. Okay, so in the exam, how they will ask us a question like 10-mark question will be like they will be given the data like first problem we have seen, no, some 12 midnight to 2 p.m. 2 a.m. 2 a.m. to 6 a.m. like that the data will be given, following load will be given. So after that maximum demand will be given. So unit generated you have to calculate. So first they may ask to draw the uh, load curve and load duration curve. Next, they may ask to calculate the demand factor. First, demand factor. Next is load factor. So, load demand factor, diversity factor, and load factor. These five things they may ask for 10 marks. So, very easy. Okay, you can get directly